Hello, my name is Juan Andrea Rușanu, and I am a PhD student at Transylvania University of Brasov. Starting with the year 2017, I was involved into the research of the brain-computer interface domain. Also, I graduated the Bachelor field of Medical Engineering in the year 2015. Then I continued my master's studies that I finished in the year 2017 at the Faculty of Product Design and Environment. Now I want to present you my application consisting in a brain-computer interface for controlling a vending machine. This is the vending machine. This is based on the Arduino Mega. Also, there were connected for pump air DC motors, and they were controlled by the motor drivers L298. After that, I developed this LabVIEW application that is integrated with the official Unicorn software applications by using the UDP data transfer. As you can see now, I wear the GTEC medical engineering headset embedding 8 sensors that are placed in these positions. Now, here is the recorder application, and now my raw EEG data is real-time monitored. In the next moments, I won't speak. I ju- I just want to be relaxed so that you can see that the EEG quality is just perfect. And it happens now. So you can see that all the LEDs corresponding to the EEG sensors positions are red. I will try to execute some eye blinks. So these are the deflections introduced by the eye blinks. You can see that all the channels are synchronized, so everything is working well. I will try to clench my teeth. Now I am clenching my teeth so that you can see this noise that is introduced into the raw EEG data. So the first phase is done. The raw EEG data is correctly recording. Uh, It can be monitored in real time. I also made some previous settings. Scaling is plus minus 50 microvolts. Bandpass filter is set between zero point 0.5 and 60 Hz, and the notch filter is set to 50 Hz because I live in Romania in Europe. I'll close this application. Next, I will open the Unicorn P300 Speller software application. It's the official suite offered by the GTEC. This is a very useful application, even if we need to pay a license. But this application offers us the possibility of detecting the P300 event related potential, and also it's possible to customize our own boards. For example, I customized my own board aimed at controlling this vending machine. So I added some pictures with juices. I will load this customized board. This should be okay. So here there are 4 letters: F from Fanta, C from Cola, S from Sprite, and P from Pepsi. When I will start this software application, the P300 Unicorn Spare Board, then there will be displayed the flashing images that will show the logo of each juice brand. So Firstly, I need to perform the calibration phase. This means I will select each of these four letters, this one, F, then C, S, and P. After that, I will focus my attention and the eyesight on each of these letters. Mentally, I will count how many flashes are covering each letter so that the application can learn to differentiate between target symbols and non-target symbols, so that the application will analyze the raw EEG data and the impact of the P300 event potential. And the output, the P300 evoked potential, will be transferred by UDP protocol in LabVIEW. And the UDP data packets are further processed in LabVIEW by an original algorithm that I implemented, so that I can get some commands based on characters that further are associated with activating or deactivating the pump air decimators that should pour the juice into the glass. So here we can see that the signal is perfect. I will run this application. I will get a relaxed position and I will focus on each of these letters. There will be 30 flashes for each character. So here we see flash mode is raw column, number of flashes per item is 30. Nevertheless, here we only have four letters, so the calibration will take short time. Okay, so the calibration is already done. Calibration succeeded, and now I should be able to select every character that I need from this speller board. There are also some further settings in the configuration window. Here we can change the flash time. Now is set by default to 100 milliseconds, or we can change the dark time. Now it's set by default to 75 milliseconds. And also I'm interested into I also want to set the number of flashes that will cover each character during the testing phase. So here we have 10 flashes. I'll try with even 8 flashes. And the wait time after item selection is set to 5 seconds. Yes, I think it's okay. We will experiment with these settings. So now I will run the LabVIEW application. The Bluetooth now should be connected. So here, I hope you can see that we have a stable LED. a stable red LED that shows Bluetooth was connected. Okay. So now I want to choose Pepsi firstly. Then I will choose Sprite. After that, Fanta, and finally Cola. So the first one is Pepsi. Okay, so I run the unicorns, the P300 unicorns per application. I'll mentally count the number of flashes that are covering the P character. Then we should expect that Pepsi juice is pouring in the glass, and also in the LabVIEW there is simulated the vending machine. So here I will set confirmation. These are the characters that we are interested into. So in parallel, LabVIEW will display the picture with juice, and also the real vending machine is controlling the corresponding DC motors that are pouring the juice in each glass. So first command is P or Pepsi. Okay, so Pepsi is now, let's see. Okay. I want to stop it. So here Pepsi was already uh, delivered. I should arrange this tube. Okay, next. I want to choose Sprite, so I will focus my attention to S. Also in LabVIEW, we can see here the UDP data packet. Uh, Here there are many characters, but we are only interested into this path. So by processing this UDP data packets, I could extract the name of the file with the picture that you have previously seen, and from this text sequence I could extract only the character P that represented the command. Here is the command, the character tree, or the figure tree that is sent to the Arduino program. Okay, so I will continue with Sprite. Okay, so Sprite was selected. You can see here it's floating. Also, the picture related to Sprite was displayed in LabVIEW. Here we have the updated UDP data packet. We can see that we have key underline s underline on dot gif. This is the picture name. This is the first extraction, and finally it returned the s character. Okay, so three character is corresponding to stop command. So please monitor when I will select F here in Arduino text box, there will be another character. And after 4 seconds, again 3 is displayed. So every time I select a letter from here, there is executed as such a sequence. So we have a state machine. There is executed the cola sequence. Here, the character 2 is sent to Arduino by the Bluetooth. Then we go to the next state, that is wait cola. We need to have this sequence, otherwise the the activation of the DC motor will be permanent. It won't be stopped. So here in this sequence, I introduced an waiting time interval. I set 4 seconds or 4000 milliseconds for LabVIEW to wait. During this time, the juice is poured into the glass. Then the next executed state or sequence is the stop call. So here in this sequence, the character tree is sent to Arduino, and in the Arduino script, it was an instruction to stop all the motors when tree is encountered, is received. And also in this state, stop cola, we checked if another command corresponding to another juice was sent. Okay, so I will continue. Now I want to select the F character or Fanta, and here we will see the juice that is pouring into the glass. Okay, so Fanta was selected, the picture is displayed. Here the juice is delivered. You can see here. So until now everything was just perfect. We observed that the difficulty of selection and the working principle is more simple to understand, to execute, because we have only 4 commands here, and because we use the flashing pictures, the significant flashing pictures, by uploading the logos of each of the juice. Again, here the UDP data package is uploaded. Here we have the complete path. The most interesting is the name of the file, key underline f underline on dot gif. This name was then extracted, and from here we are interested only in the f character that is associated with the command. Also, f is on the second position in this output Boolean array, and for the second position we had that Fanta picture displayed. Now also tree character was sent to Arduino board, so for this command Arduino stops the motor. Also here in the block diagram we can see that the communication between LabVIEW and Arduino is based on using this toolkit from LabVIEW called VISA, Virtual Instrumentation Software Architecture. It's only necessary to update the COM port corresponding to the Bluetooth module, Bluetooth AC06, that is connected to Arduino. So this is the Bluetooth module. I also previously shown you. And here also we need to add a programming sequence. And finally, I want to also select C character. This is for cola. At the same time, you will see here the picture. And unfortunately, I think that the corresponding matter for cola is not working perfectly. You will see the sound, the noise, but you won't see the juice pouring here. But let's see. So I'll focus my attention and my eyesight to the sea. So right Arduino command is 2, as you saw. The cola photo was displayed and also a sound was heard, but at the current moment, cola cannot be delivered. If you are interested to see how cola is delivered, please watch my previous two live demonstrations that I uploaded to YouTube. At In those demonstrations, I used another board, another P300 speller board, and it was the Human Faces official board offered by GTEC. So I hope you enjoyed these live demonstrations. I showed you the the recorder software application used for monitoring the quality of the raw EEG signals. Then we calibrated this customized board, and after that we tested it with random commands, and we uh, achieve both the simulation in the LabVIEW by displaying those pictures, and at the same time we experimented this real prototype of a vending machine. So this project is aimed at training students into getting familiar with the brain computer interface research domain, and also it could be a starting point for people with neuromotor disabilities to get familiar with this innovative technology, to perform the first steps. Okay, thank you very much for your attention, and I want to see you again. Thank you very much.